Okay, and this is question 10, which I'm doing as an extra question for a request from someone who emailed me through. So I will try to do extra questions if I have time. Next week I'm going to be quite busy, so you probably will find I'll only be doing the main questions from each paper, but I will try to do as many as I can. Okay, so we're looking for part 1 at finding the equation of the tangent. And what we know is that the equation of the tangent, we know two things about that. It's going to mean that it only intersects the curve at one point, but also that it shares the gradient of whatever the curve is at that point. So we need to find out what the gradient is when x equals a half. We know what the point is, and we know that x is a half, but we don't know what the gradient is. And we can see visually it's a negative gradient, so we know we should be expecting a negative answer, but we have to find the gradient. And the way to find the gradient is to take the equation of the curve, which is that, and to, and to differentiate it. So this is a composite function, so it's a function within a function, which means that we have to use the chain rule, so that means that it's going to be 3 minus 2x squared initially. So that's, remember, that's me treating this whole stuff inside the bracket like a giant x. If it was x to the power of 3, when I differentiate it, it would be 3x squared, so it's 3x squared. And now I have to then multiply by whatever the inside of the bracket differentiates to, which is, in this case, negative 2. I've slightly run out of space. If I just tidy that up and put it all together, it would be negative 6. 3 minus 2x squared. Cool. And the point of the gradient function, or the derivative in this case, is that if we put in the x value at that point, and in this case x equals a half, this gradient function will give us the gradient when x is a half, which is what we're after. So I'm going to use m because that's our coordinate geometry little notation for gradients. So if I just really carefully go in here and substitute in a half, oops, I keep on running out of space. And I work that out, I end up with a gradient of negative 24. The next part just involves me using the formula that we've used before, which is the formula for the equation of a line, when we have the gradient and 1 point, which is that. And all I'm going to do is substitute in my gradient, which is negative 24, substitute in the point, the x value point, which is a half, substitute in the y value point. If I go back here, that's 8. And then this question here specifically asks us to put the equation of the tangent in y equals mx plus c form. So we do have to do that. So that involves us expanding this out. So negative 24x plus 12 equals y minus 8. And if I tie that up, the y on that side, y equals negative 24x plus 20 is the equation of that line. Cool. So that's part 1. For part 2, we have to find the area under the shaded region. And it's kind of a little bit sneaky in this case here, because if you didn't find the equation for part 1, you'd find part 2 quite hard to do, because you need to have that equation to work it out. Yeah, so that might be why you might find part 2 hard. Normally they try to make them so they're separate so you don't get penalised twice, but in this case, not so much. So we know we've done these kind of ones before. What we're going to do, if I just really quickly draw a diagram, is we're going to do the curved area between 0 and a half. We're going to do the area under the curved part, and then what we're going to do also is the area under the straight part, again also between 0 and a half, so that part there. And then if I take that part away from that part, I'm going to get this shaded part at the top, which is what I want. So that's the first part, and once you kind of get that, the rest is just calculations and a little bit of algebra, because it's slightly harder to integrate composite functions. So if we try to integrate the area under the curve, we know that it's between a half and 0, and we're integrating that equation there. So when we integrate that, we go to our square brackets, We carry it over those x values, so it's still going to be between 1/2 and 0. And we have to be just a little bit more careful when we integrate composite functions. So we apply the same rule, we add a power, divide through by that power. So we're going to add a power of 4 and divide through by that power of 4, like that. But we also have to make sure that we divide through by whatever this differentiates to. So this would differentiate to -2, so we have to divide through by -2 as well, so that they cancel out when they differentiate. So if I divide through by -2 as well, that's the same as multiplying by 1 over -2. If you get really good at it, after a while you can kind of straight away combine that with this fraction here, but you can always take it slowly for now. So that would mean that it's the same as 1 over 8, which is negative, 3 minus 2x all to the power of 4 between 1/2 and 0. I'm just going to move things up like that to give myself a bit more space. Okay, what happens now? What happens now, people? We substitute in our 1/2 and we substitute in our 0 to get our area under the curve. So if I substitute 1/2 into this whole expression, then I end up with -2. And if I substitute 0 into this expression, I end up with -81 over 8. So just be careful that you do write out like that so that you can see that you're going to end up taking away a negative number, which means it becomes positive. So if I work that whole thing out, so I end up, calculator's gone crazy, 65 over 8, ooh, like that. So that's the area under the whole curve, which is the largest part. I want to work out the area under the tangent, under that tangent line, and then I can subtract that away to get the final area. So let me just move that up as well, bit by bit. Cool. So the area under the tangent, so let's do the same thing as before. It's going to be integrating between 1/2 and 0, and that equation was -24x plus 20. So when I integrate that, I'm going to get x squared, and I'm going to divide through by 2, which will make that -12, and I'm going to get 20x. And that's all between 1/2 and 0. So when I substitute in that twice, when I put in 1/2 into that, I get 7, and when I put 0 in, I actually just get 0. So the whole thing just ends up being 7. Cool. So then I go back here, and so my total area is going to be the area under the curved part, which is 65 over 8, minus the area under the tangent, which is 7, which ends up being 9/8.